So let's take a look at applications of vectors. Now before I get started with the problems, I just want to review a little bit on polar coordinates. So remember that if you're given r, a certain radius value, x is going to equal r cosine of theta, and y is going to equal r sine of theta. And so if I were to draw a triangle here, in the unit circle, if we had the radius as the hypotenuse, and the radius is usually just 1 in the unit circle, and this is our theta value. So this x component will be r cosine theta once again, and the y component will be equal to r sine of theta. Now if we were to draw vectors in this case, let's say we have a vector with its x and y components. So let's just call this vector A. Instead of r, this is going to be the magnitude of vector A. So the hypotenuse will be the magnitude. The x component will be the magnitude times cosine of theta, and the y component will be the magnitude of vector A times sine of theta, while this is going to be the theta value, or the angle. So this can be very useful information when it comes to work or word problems. So this information can be very useful when it comes to application of vectors word problems. So let's say for number 1, two forces, force 1 and force 2, with magnitudes of 10 pounds and 12 pounds, act on an object at a point P as shown in the figure below. Find the resultant force F acting on P, as well as its magnitude and its direction. So notice right away that force F is going to be that resultant force. And so it is the result of adding force 1 and force 2. So in order to find the components of force F, or the resultant force, we must find the components of force 1 and force 2 and then add them together to get our resultant force F. So let's just go ahead and start with finding the components of force 1. So if I were to draw this on an xy coordinate plane here, and I'll go ahead and draw force 1 on the left. So notice it's on the negative x-axis and on the positive y-axis. And force 1 is given to us as having 10 pounds of force. So the magnitude is 10 pounds. And so we need to be able to find the x and y components. And also notice the degree that is given to us, or the angle, is 45 degrees. So remember that x is going to equal to the magnitude. So x is going to be equal to the magnitude of the force times cosine of theta. In this case, theta is 45 degrees. And y is going to equal to the magnitude of the force times sine of 45 degrees. And in this case, remember that x value is negative here, which means we'll have a negative x. So it'll be negative 10 times cosine of 45. And then the y value would be 10 times sine of 45 degrees. So if I were to rewrite force 1 in component form, force 1 is going to be equal to the x component, which is negative 10 cosine of 45 degrees, and then the y component, which is 10 times sine of 45 degrees. So now let's go ahead and find force 2 and its components. So force 2, if I were to draw on a separate coordinate plane here, notice the x and y, it's both positive, and the resultant, or the force that's given to us, the magnitude, is 12 pounds for force 2. So the hypotenuse will be 12 pounds. Now the angle that is given to us is 30 degrees, and so the x component is going to be the magnitude, which is 12, times cosine of the angle, 30 degrees. And since it's the positive x-axis, we just keep it positive, we don't need to change it to negative. And the y value is going to be the magnitude, or the y component is the magnitude times sine of the angle, 30 degrees. So the resultant, or not the resultant, force 2, if I were to write that in component form, we're going to write it as the x component, which is 12 cosine 30 degrees, and then comma the y component, 12 sine of 30 degrees. So now remember, force 1 plus force 2 gives us that resultant force. So what we have to do is add these vectors together and add the components. So the resultant force is going to have the components negative 10 cosine of 45 degrees plus 12 cosine of 30. So that is the x component. and the y component is going to be 10 sine of 45 degrees plus 12 sine of 30 degrees. And that is the y component. Now, in order to find the magnitude of the resultant force, remember the magnitude is going to be equal to the square root of x squared plus y squared. So we can go ahead and just use a calculator and plug in these numbers. So basically I will take the square root of this value squared and then plus this value squared, the y value. And that will give us the final answer for the magnitude. And remember to, if you're using a graphing calculator, to switch your mode to degrees, not radians. And so the magnitude of the resultant force, you should get around, when you plug into your calculator, 13, let me write that again, you should get around 13.5 pounds of force. So now in order to find the direction, we're basically trying to find that theta value. So if I were to draw this triangle, or the vector f, one more time on a different coordinate plane, the resultant force looks something like this. We have already found the magnitude, and so we have the x component and we have the y component already. This is the x component, this entire thing, and this entire thing is the y component. And then we have our theta value that we need to find here. So remember, in the unit circle, that tangent of theta is equal to y over x. So if we want to isolate theta, we have to arctangent or inverse tangent both sides. So theta is going to equal to arctangent or inverse tangent of y over x. So once again, we're just going to take the inverse tangent of this entire y value divided by the entire x component, and then we'll get our theta value. And when you plug it into your calculator, you should get a theta value, or the angle, of around 76 degrees. So that is the final answer. So now for number 2, let's say a woman walks due west on the deck of a ship at 3 miles per hour. The ship is moving north at a speed of 22 miles per hour. Find the speed and direction of the woman relative to the surface of the water. So here let's draw two vectors. Let's draw a vector of the woman walking due west on the ship, and let's draw a vector of the ship moving north. So a woman walking west on a ship is going to look something like this, and she's going at 3 miles per hour. And so a ship is moving north, and this is going to be a much bigger vector because it has a much bigger magnitude of 22 miles per hour. And so we have to find the speed and direction of the woman relative to the surface of the water. So let's go ahead and combine these two vectors. So let's say this is the second vector, the woman is the second vector, and the ship is the first vector. So if we combine the initial point of the second vector with the terminal point of the first vector, we'll get a new vector like so. So this is going to be the 22 miles per hour, this is the 3 miles per hour, so the new vector is going to look something like this. So this is going to be the vector of the woman relative to the surface of the water. So since we're going to try to find speed, then I'll just call it the magnitude of the velocity, since the magnitude of velocity is another word for speed. Since the magnitude of the velocity is another term for speed. Now remember, in order to find that, this is a right triangle, so we can just use Pythagorean theorem. So we can just say that the magnitude of the velocity is going to equal to the square root of x squared plus y squared. So if our x value is 3 and our y value is 22, I'm just going to go ahead and use a calculator. And so we'll get the absolute value is equal to the square root of 3 squared root is 9 plus 22 squared, which is 484. And so we'll get the square root of 493. And so that is the exact magnitude of the velocity, or the exact speed. Square root of 493. So now, in order to find the direction the woman is going on relative to the surface of the water, we basically have to find this angle theta. And so if I were to draw this on a coordinate plane and sort of label it like a compass, so let's say we have north, east, south, and west. Now let's go ahead and find this theta value in terms of degrees. So make sure you switch it to degrees, your graphing calculator, when you calculate this. And remember that theta is going to equal to inverse tangent or arctangent of y over x. So for our x value, or our y value here is 22, and our x value is 3. So we just take 22 over 3. And so the answer you get is around 82 degrees. And be careful here, because theta is not actually 82 degrees, and I apologize for my poor drawing, but 82 degrees, if I were to draw more to scale, would be the degree or the angle from here to here. So this is going to be that 82 degrees. Now in order to find theta, we can just simply subtract 82 from 90. So we get 90 minus 82, or in other words, we get around 8 degrees as our theta value. Now when we talk about direction of ships, we typically write this, or we typically write the direction in terms of bearings. So we started at the north direction here. So let's just go ahead and write north. And then we're going theta to the west. So 8 degrees towards the west. So the way we write this is north 8 degrees west. And that is the direction and the speed of the woman relative to the surface of the water. Now another way you could have also found the theta angle is you could have said that tangent is also opposite over adjacent instead of y over x. So if you did that instead, and you did theta equals inverse tangent of 3 over 22, then you would have gotten directly to the correct answer of around 8 degrees. And if you get 82, that's fine. You can also just subtract it from 90, and you'll still get the correct answer. But realize that if you do y over x, sometimes you have to make that extra step of subtracting it from 90 degrees.